Have you ever noticed how changes in the weather can sometimes affect seemingly unrelated natural phenomena, like the water levels in a nearby lake or well? It might seem surprising, but even the air above us plays a critical role in what is happening beneath our feet. Atmospheric pressure directly influences shallow groundwater systems because the changing weight of the atmosphere is transmitted through the land surface to the water table. This influence is most noticeable in unconfined aquifers, where the water table is exposed to the atmosphere through the soil and porous rock, causing water levels in wells to fluctuate with barometric changes. The core mechanism behind this phenomenon lies in the physical connection between the atmosphere and the groundwater. When atmospheric pressure increases, the air exerts a greater downward force on the ground and, more importantly, directly onto the exposed surface of the water in an unconfined aquifer. This increased pressure pushes down on the water table, causing the water level in an observation well to drop slightly. Conversely, when atmospheric pressure decreases, that downward force lessens, allowing the water table to rise. To observe and understand this effect, hydrogeologists carefully monitor groundwater levels in wells while also recording local barometric pressure. By comparing these two datasets, they can identify correlations and quantify the extent of atmospheric influence. Subtracting the atmospheric effect from raw water level measurements helps researchers isolate true groundwater flow dynamics, providing a more accurate picture of how water moves through the subsurface. This interaction is often quantified using a concept called barometric efficiency, which is the ratio of the change in water level to the change in atmospheric pressure. A typical unconfined aquifer might have a barometric efficiency of less than 1%, meaning that for every unit change in atmospheric pressure, the water level changes by a much smaller amount. However, even these small changes are vital for precise hydrogeological investigations and understanding aquifer responses to natural forces. Understanding how atmospheric pressure influences shallow groundwater is crucial for anyone studying or managing water resources. By accounting for these daily and seasonal fluctuations, we can make more accurate assessments of groundwater availability, better interpret pumping tests, and develop more effective strategies for protecting our precious subsurface water supplies.
If you love learning about water, like, subscribe, and keep exploring with us.